16 divided by 2 times 2 plus 2 equals question mark. 2, 32. Oh, what a little rascal.
Americans and your correct education system, y'all never heard of the thing BODMAS in primary school? Basically, B brackets of simply multiplying the brackets with a number outside of it. D division comes third, me multiplication fourth, addition, subtraction, the answer is addiction. Okay, addiction comes fifth, subtraction, the answer is 2, the frick.
All right, let me do this in Paint. I don't know if this is an American school thing, but I hate that way of writing it. Okay, Paint. Here we go. Well, hello there, kids. Welcome to Click's Academy. So today we have a legendary mathematical problem that the internet is up in arms about. It's a very controversial issue. We have 16 divided by 2, and then we have parentheses of 2 plus 2 equals what? Oh my god. And then this beautiful person has a rule in mind which is called BODMAS that I have never heard of in my life, and I don't understand why American school systems do this. If I want to rewrite this in a pedagogical way that anyone can understand, which I think is just common sense, I would write it like this: 16 divided by 2, parentheses, 2 plus 2. Because this lineup makes it so much more clear what is actually beneath the division mark, right? This is the common sense way of writing it. And then it's pretty obvious that this is 8 times 4, which is in the parentheses, and this is 32. Astounding, right? It would have been 2 if you put an additional bracket here, because then it turns out to be 16 divided by 8, which is 2. So it's all about where you put the bracket. But all in all, just write the whole equation like a functioning human being.
So I hope you learned something. Smash the like button if you want. Click to replace all school.
My god, the world would be even worse than it is today. The owner of this Chevrolet Bolt electric vehicle has done what no electric manufacturer has done so far, something completely logical. We always wonder why these vehicles weren't designed to use the energy that produces the spinning wheels to charge the vehicle's batteries. This man did it at home. It's a generator that produces a current which charges the batteries. No need to stop and charge the batteries at the charging station or charge the night at home. While the vehicle is running, it charges the batteries. Simple, elementary, my dear Watson.
All right, welcome back to Clicky Kitty School University. So today we are gonna do energy.
Amazing. So we have this very fascinating problem right here. So basically, you can put it this way. If this is the battery of the car, right? There is a little law in thermodynamics that say that you can't just create energy out of nothing. So basically, if you use this battery to pump it into the engine that we will denote as E, and this energy that goes here is X, all right? The engine will then produce this thing right here, which is an energy that goes into the generator, which we'll call G, that then produces into the battery, right? But then, of course, the engine also has a little bit of spill, like, you know, friction, heat, all that kind of stuff, and just general inefficiencies in the mechanical stuff, mainly friction. And that goes out here, and we can call that Y. So basically what happens is that this battery produces X energy into the engine pumps out Y energy in friction, and X minus Y back into the generator, which then also has, of course, a loss factor that we would call like Z. So what actually goes back into the battery is X minus Y minus Z, which is then, of course, less than X. So by doing this, you would just run out of battery, depending on how much friction and inefficiency you have in the system. But if you leave this running, your car will just run out of battery. This is not charging anything. There are systems in cars that charge your electric battery, and this goes for practically any car, but they have a bit of more systems when the car is like a hybrid and stuff. For example, when you brake, there is a generator tied to the brakes that generates a bit of efficiency. When you roll, for example, downhill, and you use what, at least we in Sweden, call engine braking, that's typically a generator that kicks in and like brakes it, so when you just roll downhill, you recharge the battery, and so on and so forth. But no, it doesn't work like this. This is just ludicrous. There's a reason why we don't do this. This would be like trying to hook like an electric wire to itself and expecting it to charge. It doesn't work. The frick is the answer. Coca-Cola plus cola is 30. Cola plus hamburger burger, 20. Burger fry 9. So the Coca-Colas are 30 combined, means each cola is 10. 10 is actually 2 burgers, so that means a burger is 5. So then the fries should be 2. Alright, so you have a burger, that was that 5 or whatever, and then we have 2 and 10. 17? Is that it? Alright, genius. You know what I hate about these puzzles? They don't actually teach you the actual method for solving things like this because they always give it away with the first formula. Let me show you what I mean! Click Academy time in Paint! Woo! Alright, welcome to Click Academy, everyone. We're gonna do math. It always is fun. Math. Smiley. So there is a rule in mathematics that you can solve as many variables as you have equations. So for example, let's say you have two variables, x and y. You need two equations to be able to solve for these variables, otherwise you will get what is called a parameter solution, which means that one of the answers could be anywhere across basically a straight line, and then of course depending on how many variables you have, but that's generally called a parameter solution. So let's say for example we have x plus y equals 3, and then you have for example 3x plus y equals, like, I don't know, let's just pick 6. This is a bit trickier than that hamburger thing, because now all of a sudden you realize, wait a second, how do I solve this? I can't break anything out of the first equation. I can't break anything out. Let me move this down. Oh, there we go. Professional. I can't break anything down in the second equation either. How do I solve this? Well, a trick to solve this kind of thing is either to just take this entire thing, times minus 3, and move it down to cancel out the x, or if you want to do this more simple, you can, for example, rewrite the first equation as x equals 3 minus y. Then you put this bad boy into there. And then you can solve this entire equation, because then at the end of this thing, you will only have y's. So you will actually get 3 times this x, which is 3 minus y, and then plus y, equals 6. And a bit of brain gymnastics here. Let's see now. So this will be 9 minus 3y plus y equals 6. And this means that we can break out y, because we have minus 2y here. Let me do this a bit less cluttery. So then this equation, we can solve this bad boy, and we can, for example, take y to this side. So we have 9 plus y equals 6 plus 3y. And then we cancel this out, so we have 9 equals 6 plus 2y. And then we just like take minus 6 on both sides, and 3 equals 2y, and y is equal to a half. Yum. And then to solve the other thing, of course, you just squeeze this bad boy into here. And then you get that x is also a half. No, x is 2.5. Sorry, wow, I'm a boomer. Which means this in turn, let's do the equality things here. Ah, there we go. That means that x is 3 minus a half, which means that x is 2.5. So this is how you solve it when you... What a freaking mess. This is how you solve it when you don't just have the first line giving you the answer to what x is. So you can actually use all the equations to your advantage, and for each equation you can solve one additional variable. If you have x, y, z, you need 3 lines of equations to properly solve it. Anyway, that was Click Academy Math. Beautiful. Moving on with rest of godforsaken video.
Please don't use calculator, use your brain. 50 plus 10 times 0 plus 7 plus 2 is question mark.
PEMDAS. Parentheses, exponents, multiplication, division, addition, subtraction.
There is no parentheses. You can't go by that if you don't have none. Oh my... Ask any gosh darn heckin' math teacher to go back to school. All you do is solve left to right. The answer is 9, so please go back to school.
It is okay to be wrong sometimes. Part of being human is being wrong sometimes. But it gets kind of comedic when you're so confident about your wrong opinion that you call everyone else a moron and you tell them to go back to school when you obviously never showed up for a single god-frickin' day. Well, good day, kids. Today on Click Academy, we're gonna do some beautiful math. So on this channel is always a controversial hellhole whenever I go through a basic mathematical problem. Once upon a time, I believe we did this problem. 16 divided by 2 times 2 plus 2, because I want to demonstrate why PEMDAS is a piece of poo-poo. Don't get me wrong, it's a perfectly fine rule to memorize mathematical operations in basic math, but it's not like a mathematical definition in itself, and I'm gonna show you why. So in this problem, for example, that we have, it's usually rewritten like this in any kind of coherent math. And this is very controversial because depending on how you interpret the problem, you get 2 different answers. But in reality, it's just 16 times 2, which is 32. That's essentially the conclusion of this baby. But PEMDAS, to me, doesn't really make a lot of sense, because if we backtrack here for a second, I do a new file. No, I don't want to save this. Okay, well, oh, damn, I need a title. Click Academy. There we go, beautiful. Let's say, for example, we have a problem that looks like this. 2 plus 1 squared. Oh my god, what is this? PEMDAS tells us to do the parentheses first, which means that we get 3 to the power of 2, which is 9, right?
But what if we switch it around? Oh my god, what if we do this one first instead? Well, you will be shocked to realize that we get exactly the same answer.
My point is that if you know how to rewrite things, you get the exact same answer with everything you do. The only thing you really need to remember is that multiplication and division comes before plus and minus. PEMDAS in itself is not a mathematical definition. End of story. Please go nuts in comments. Thank you.
You have to respect other people's opinions.
Their opinion. 3 squared is 6.
It's literally 6. It's 6, y'all. I'm smoking. It's literally 6, but okay. It's 6, y'all. Don't understand exponents work, and it shows.
Don't be so confident and condescending when you suck!
Alright, everyone, let's bring out paint. It's time to do this the hard way.
Hi, ladies, gentlemen, friends, welcome to Click Academy. So today, we're gonna do 3 squared, apparently, because that's difficult. So 3 squared means that you take 3 times 3, which is 9. If you really want to do this really thick, you can also think of this as 3 plus 3 plus 3, which is 9. Thank you so much, Nobel Prize, here I come. Thank you for coming to my TED Talk. Try 9 times 9, that'll show them.
18?
Bro.
You don't have to tell me, I already know I'm right.
Well, good evening, lotties, lurkers, and horkers. Welcome to Click Academy. So, on today on Humanity... Thank you for listening to my TED Talk. A bat and a ball are $1.10, and the bat is $1 more than the ball. How much is the ball?
How the hell did you get the second ball? There is simple word incompleted price 1.1, and then the bat is $1 more. Simple math, 1 plus 1.1 is 1.1. So by fact, the bat costs 1, the ball is 0.1. Simple as that. Maybe in the USA you got teached the other way. Teached.
Well, then the bat would only be 0.9 times more expensive, wouldn't it? It's time for Click Academy to learn them oofs. So welcome everyone to Click Academy. Click Academy. So today we're gonna do an absolutely beautiful question. So the premise of this question is the bat plus the ball costs $1.1, and we can just denounce it as the bat as X and the ball as y equals to 1.1, right? Absolutely beautiful. The second equation we are specified in this is that the bat costs $1 more than the ball, which means that the bat, as we have as x, is going to be equal to 1 plus y, right? Because it's $1 more expensive than the ball. So how do we solve this? Well, the rule of math is that you can solve basically one variable per line of equation. So the nice little trick here is to put this x into this one, which is of course this part of the equation. So this means that if we rewrite the first equation with the x put into this, means we actually get 1 plus y again equals 1.1. Simplify this bad boy, and you are gonna get eventually 2y equals 0.1, which means that y, which is the cost of the ball, is 0.05. That's a pretty affordable ball. Heck yeah. Okay, so now we just put this y into the initial equation or something we have here, for example. It's probably easiest, which means that x is going to be 1 plus 0.05, which is 1.05. Absolutely beautiful. And do we check the premise of this? Yeah, it looks like the bat is indeed $1 more expensive than the ball, and combined they are 1.1 expensive. Thank you so much for showing up to Click Academy, where I do weird things in paint. Moving on. I can do this professionally. I am doing this profession. I get paid for this. I get paid for doing, like, I don't know, 9th grade math in paint. Frick yeah. A good old theoretic science. Gravity is just a fairy tale with 0 experiments to prove its actual existence. How do mosquitoes fly if there's a strong force holding everything down? Why is it when you fill a balloon with 50% helium and 50% oxygen, it still floats? Some forms of rain clouds are so heavy if they landed on us we would die or get seriously hurt. How does those clouds stay in the air if gravity pulls everything down? Seems like my approach is way more scientific and repeatable in experiments. You know the laws of science, not theory. Click Academy time, booyah! Well, good evening, lotties, lasses, and lazzles. Welcome to Click Academy. Our first experiment of the day is to show that you can indeed do repeatable experiments that demonstrate gravity. Cool. Now moving on to the next one. Alright, laddies, lads and lasses, welcome to Click Academy. So today we are going to look at some beautiful science together. The first problem is if we have a mosquito with wings like this, and it has little eyes, of course, because it's a mosquito and it's very happy. So if this thing is flying and we have a gravitational pull down here, how on earth can it actually fly? Well, what a mystery. So let's figure it out together. The force of gravity is equal to g, which is a gravitational constant, 9.91, I think, on Earth or something like that. Feel free to roast me in the comments. And then we have mass 1 and mass 2, which are the masses of the two objects we're comparing gravity between. So in this case, mass 1 would be the Earth and mass 2 would be the mosquito. And then we divide this by the radius squared, basically the distance between the two bodies of mass. So in this case, if the m2, which is the mosquito's mass, is kind of tiny, the whole F is going to be kind of tiny too. Makes sense, right? Multiplied by m2, tiny ass mosquito, tiny ass gravity. Which means that for the mosquito to be able to fly, the force upwards when it's flapping its fat little wings has to be at least F as well. Which of course, counting that air actually has a certain density and that kind of stuff, it doesn't take too much flapping to make up for this when the m2 is very tiny, right? So the fact that a mosquito can fly despite there being a force downwards isn't particularly far-fetched. Why is it when you fill a balloon with 50% helium and 50% oxygen it still floats? Well, if you do indeed have a balloon like this, you can have a force upwards and a force downwards, and as long as this gravitational force is roughly the same, you know, it's going to heckin' fly. If it's the exact same force, it's going to stand still midair. It floats because it's lower density and everything around, the same kind of logic when something flows on the water. Imagine you hanging a rock in a rope underneath a boat. That's basically the same philosophy as you know, a balloon, only that one happens in air and one in water. It's all about having some kind of matter around it that has a higher density than whatever is inside of this one. So as long as you have a mass that can actually expand this balloon, you know, because, you know, if there's nothing there, it's gonna smack down. You're not gonna have anything that can float. So as long as you have something that can fill it out, but still have lower density than everything around it, it's going to give you some kind of floaty force. It's kind of nifty. And then the last one, if clouds landed on you, you would die because they weigh a lot. I mean, sure, all the air in the atmosphere weigh a lot too if you combined it all, but that doesn't mean, you know, there's gravity and density and very low density, and it's not like a solid object that's gonna smack into your face. I'm not gonna... Click Academy done for the day, we're done. Doctor, sir, the surgery has a 50% survival rate, but don't worry, my last 20 patients have all survived. Normal people, mathematician, This demonstrates the gambler's fallacy. It is the incorrect belief that if a particular event occurs more frequently than normal during the past, it is less likely to happen in the future. Yeah, that's very true. You can think of it as just a statistical tree, basically. Should we do a Click Academy? Click Academy? Paint! My favorite program, baby. Booyah! Good evening, laddies, lasses, and lasses, to Click Academy. So today, we are talking about statistics and the likelihood of things happening. So the most easy way to think about this is just a statistic tree that goes around like this. And to make it easy, let's just say it's 50-50 at each little 5-5, we'll call it. And for each of these choices, you go down the side, and basically you end up at a resolution. So this leads to the point that basically if something happens only on this side, for a long time, it means that people will think you will do the other option after a while, which isn't correct because at every single little point here, every single crossing you can call it, you still have locally, so to say, a 50-50 chance of anything happening, right? It is only when you zoom out and look at the whole thing as a whole that these larger statistics come into play, when you have 0.5 to the power or whatever. And that is how it works. So when you stand here and you're about to do the gambling thing, it's still 50-50. It doesn't matter how your coin has flipped before that. What your coin has flipped before that only matters if you look at the whole thing as a whole before you start, not when you stand at this specific crossing. That is what Click Academy for the day. My drawings are amazing. Pedagogology is very good, yes.